So our study is about how LLM2 can be empowered by the ACTR framework. So why this is important? Because LLM2 at this moment, we all know it's very helpful, but it has limitations. It will hallucinate. Basically, it does not have a good long-term memory, and it will lose focus from time to time. And specifically, we want to address the long-term memory issue and the losing focus issue in our study here. So to address these two issues, we have researched on the internet and we found a framework called ACTR, which could be potentially used to address these issues. And that becomes our research topic. We want to explore how the ACTR and how it what and if it could be used to reduce these two issues. And we designed this whole tool and our study in two steps. The first step is we're gonna implement the ACTR tool or the LLM tool with the ACTR framework. And the second step is we're gonna conduct an experiment with the traditional LLM prompting method, zero shot prompting, to compare its performance. So when designing the tool, we leverage the traditional ACTR framework as this is here. And one thing to call is we do not focus on the visual parts because it will introduce extra complexities for our research topic. And we only use text to simulate the visual inputs. And key components of our implementation is we use Python to run this whole code, and we use GPT-4o to simulate certain parts of the components. And when designing the local memory, we use JSON file to store locally. And when we are using this Go module, we use the LLM-driven method. And for the production system, we use the rule-based production system, while the matching and selection is also done by the language models. And the real external world information and the actions is simulated by language models. So after setting all this up, we conducted the experiment based on the scenario of a city transit scenario. So basically, imagine you go to work every morning, and we simulate this scenario, and we want to compare like how the GPT-4o prompting versus the ACTR2 framework, how the performance is different. So how to define a success scenario or the success trial? It means like the agent or the language model successfully went from his home to his office. And if on the road there is any hallucination or any failure happened, it means like this trial is not succeed. So we run totally 6 episodes, and each episodes with different number of incidents and repeated by 10 times to ensure to take the average of the performance. And this is the final outcome. So basically, we can see when the when the number of incidents is small, both the zero shots prompting and the ACTR2 are both good. However, when the number of incidents goes up, the ACTR2 is performing much better with 80% or 70% accuracy, while the zero shot prompting is only providing a like 40% or 50%, 60% accuracy. And this indicates that our ACTR2 could indeed resolve these problems against the zero shot prompting method. And some limitations about our work is currently we only talk about one scenario of the city transit, which could be expanded in the future. And another is like our framework is the simplified ACTR. Like we have several assumptions there, but if we remove those assumptions, for sure our tool could better simulate the real world. And also it's like our sample size or the episode size is limited, so we're gonna explore if the number of incidents keep growing, would this tool be still as efficient as it is at this moment. Yeah, that's all about my tool and my research topic. Thank you for your time.